Welcome to This Explainer. Today, we're taking a fascinating journey into what a lot of people consider the absolute bedrock of enterprise cybersecurity, identity and access management. Now, I know what you might be thinking. It's so easy to mistake this topic for just dry administrative paperwork, right? But we're going to completely reframe that today. Because identity and access management, it's actually the ultimate digital castle defense system. It's this highly complex, layered mechanism for controlling systemic trust.
Okay, let's dive into this. Here is our roadmap. We'll be hitting 5 critical checkpoints: the foundations of access control, identity lifecycles and authentication, navigating access control models, federated identity and SSO, and finally, cryptographic threats and defenses.
To really understand just how critical this journey is, consider this number, 13%. This single domain makes up exactly 13% of the entire standard CISSP curriculum. I mean, that is a massive operational weight. And honestly, it proves the incredibly high stakes of what we're about to learn, which is basically how we establish exactly who someone is and precisely what they are allowed to do. Section 1, Foundations of Access Control. Before we can even verify identities, we really need to understand the core rules that govern the perimeter. So the architecture of identity systems is fundamentally rooted in 3 core access control tenets. First up is need to know, which is exactly what it sounds like. It restricts the visibility of data exclusively to the people who literally require it for their current tasks. Second, we have least privilege. This governs the actual execution of commands, making sure subjects have only the absolute bare minimum permissions necessary, no extra access just for convenience. And finally, separation of duties. This intentionally splits up high-risk workflows across multiple, distinct roles to establish internal friction against fraud. When you put them all together, these 3 rules synergize perfectly to dramatically shrink the blast radius if a compromise actually happens. And this brilliantly illustrates how these controls have to be applied across 2 completely different yet totally connected worlds. On one side, we've got the physical access environment. Think geographic barriers, mechanical turnstiles, biometric door scanners, physical guards. Then, on the other side, we have the logical access environment. This is your digital data access, relying on cryptographic tokens, central directories, and firewalls. Now, the absolutely crucial takeaway here is that these 2 realms must converge. An unmitigated breach in your physical environment almost inevitably compromises your logical environment, and vice versa. You literally can't have one without the other. Moving right along to Section 2, Identity Lifecycles and Authentication. Here's where we shift from the architectural perimeter to the actual gatekeepers. This whole process is strictly defined by something called the sequential AA framework. Step 1, an entity claims an identity. That's identification. Step 2 is authentication, which is the mathematical cryptographic process of actually verifying that claim. Are you who you say you are? Step 3 is authorization. This grants specific rights based on that verified identity. And finally, step 4, accounting. This ensures that all subsequent actions are immutably tracked and logged. This exact sequence is how an unverified subject transforms into a fully trusted principal whose actions are on the record. Now, that critical authentication step we just mentioned, it relies on 3 primary categories, or factors. Factor 1 is knowledge, something you know. Think of that password you've had to reset 3 times this week. Factor 2 is ownership, something you physically possess. But keep in mind, legacy memory cards are super easy to clone. Modern infrastructure really demands smart cards with active built-in computational power. Finally, we've got Factor 3, inherence, something you are. Utilizing biometric fingerprint or iris scanners gives us an exceptionally high degree of non-repudiation, simply because these physical traits are biologically bound directly to you. You literally can't leave them at home. So the crucial point is how we actually combine these factors. Relying on a single factor is inherently vulnerable, right? So we use multi-factor authentication, or MFA. But wait, the architectural definition here is incredibly strict. True MFA requires at least 2 factors from entirely different categories. Listen to this. Requiring a password and a memorized security question, that is not MFA. That's just strong single-factor knowledge. To truly exponentially increase the technical difficulty for an attacker, you absolutely must cross those categorical boundaries. But you know, an identity isn't just created and then forgotten about. It's actually a highly dynamic state machine that travels through what we call the identity lifecycle. It kicks off with provisioning, establishing initial access based strictly on least privilege default policies. Then comes active monitoring. This is a prolonged phase of continuous entitlement reviews. And here, dynamic just-in-time, or JIT, access is an absolute necessity to stop standing privilege creep. We do not want to give adversaries pre-authorized network pathways just sitting there waiting to be exploited.
Finally, the lifecycle concludes with absolute deterministic deprovisioning.
And failing at that final deprovisioning step? Well, that introduces one of the most severe threats to an enterprise: ghost accounts. These are dormant identities belonging to departed personnel that somehow have retained active, high-level systemic entitlements. Because they rarely trigger standard behavioral anomaly alerts, the person isn't there to do anything weird, these orphaned accounts are prime, highly sought-after targets for advanced persistent threat actors. They are basically looking for long-term undetected persistence inside your network, and a ghost account is the perfect hiding spot.
All right, Section 3, Navigating Access Control Models. Once someone is actually inside the castle, we need architectural rules to dictate exactly what they're allowed to do.
At opposite ends of the authorization spectrum, we find two totally distinct paradigms. First, discretionary access control, or DAC. This is a highly decentralized model that grants absolute administrative authority right to the data owner. It's super flexible, sure, but it relies heavily on user competence, which, let's be honest, makes it extremely vulnerable to insider threats and malware. In stark contrast, we have mandatory access control, or MAC. This is an incredibly rigid, government-level architecture. It completely strips the data owner of all permission control. Instead, it relies on a strict taxonomy of security labels and operational clearances that are evaluated directly by the operating system itself.
To bridge that massive gap between discretionary chaos and mandatory rigidity, the industry standard is role-based access control, or RBAC. This model abstracts permissions away from individual users and instead bundles them into functional roles that logically mirror a person's exact job responsibilities. It dramatically mitigates administrative errors. However, and this is a big however, in massive, highly complex global environments, RBAC can suffer from something called role explosion. That's where the number of unique roles actually outpaces the number of users. So, to solve the limitations of roles, we reach the absolute apex of modern zero-trust authorization theory: attribute-based access control, or ABAC. ABAC makes exquisitely precise decisions by dynamically evaluating real-time data across 4 distinct categories. You have subject attributes about the user, object attributes about the data, action attributes dictating the operation, and critically, contextual and environmental attributes. Think about evaluating the real-time geographic location of an IP address or the exact time of day before granting access. It's incredibly powerful. Moving on to Section 4, Federated Identity and SSO. We're shifting away from localized castle walls to the modern challenge of borderless cloud networks. And this poses a massive, absolutely critical question for security engineers. How do we securely authenticate an identity when there is no longer a localized physical network perimeter to protect, when everyone is everywhere? The answer lies in identity federation, establishing a mutual, cryptographically verified chain of trust across completely disparate organizations and external cloud services. Let's move to and see how this builds across the 3 globally dominant federated protocols. First up is SAML 2.0. This is the legacy heavy hitter, utilizing complex XML documents to facilitate enterprise single sign-on. Next is the OAuth 2.0 framework. Now, this one explicitly is not for authentication, but instead uses lightweight, opaque tokens specifically for delegated API access. Finally, we have OpenID Connect, or OIDC. This protocol utilizes verifiable JSON web tokens, making it the premier choice for modern, consumer-facing, mobile and single-page applications. It's really vital to understand the historical context between those last two. Because OAuth was designed strictly for authorization, application developers were frequently, and quite dangerously, misusing opaque OAuth access tokens as proof of human identity. This led to widespread impersonation vulnerabilities across the web. So, OIDC was formally introduced to fix this exact problem. It laid a dedicated standardized identity verification layer directly on top of OAuth, parsing cryptographically verified identity claims right inside the client application using those JSON web tokens. Pretty clever, right? This brings us to our final section, Section 5, Cryptographic Threats and Defenses. This is the high-stakes battlefield where these federated protocols face sophisticated manipulation. Within SAML ecosystems, the paramount existential threat is the XML signature wrapping attack. This is where an adversary intercepts and mathematically alters the XML document's tree structure to completely bypass validation. Proactive defenses are absolutely mandatory here. You must enforce strict localized XML schema validation, you have to explicitly reject legacy SHA-1 hashing architectures, and you need to protect your private signing keys by physically safeguarding them within highly rated hardware security modules utilizing a minimum of 2048-bit RSA keys or 256-bit ECC. Now, what's really interesting about this slide is seeing exactly how we protect modern OAuth architectures. The legacy implicit flow is highly vulnerable because it completely bypasses secure back channels and returns tokens directly to the client browser, exposing them to malicious scripts. Yikes. The modern standard rigorously defends against this by utilizing the authorization code flow augmented with PKCE, that's proof key for code exchange. PKCE mathematically neutralizes interception attacks by requiring a dynamically generated secret verifier. This ensures that even if an authorization code is stolen in transit, the attacker is completely unable to exchange it for an access token. And that brings us to our conclusion. As we've seen today, managing identity isn't just about handing out passwords, it's about continuously securing the very fabric of enterprise operations. To quote the foundational truth of this domain, only through the stringent, unwavering adherence to these highly specific cryptographic boundaries and validation rules can modern organizations safely leverage the immense power and scalability of federated identity and access management architectures. So I leave you with this question to ponder. If your physical perimeter completely vanished tomorrow, are your digital identities strong enough to defend the castle on their own? Thank you so much for joining me on this explainer. Until next time, keep your identities verified and your privileges leased.
For decades, enterprise security relied on a simple geographic assumption. Trusted users were inside the building, and threats were outside. The traditional castle and moat network perimeter was designed to protect that boundary. Today, hybrid architectures have rendered that assumption untenable. By pushing applications to the cloud and employees to remote endpoints, organizations are fracturing the perimeter into thousands of isolated floating nodes. In this distributed environment, legacy binary authentication fails. Passwords are shared secrets stored on central servers, making them vulnerable to credential stuffing and centralized database breaches. The enterprise reality has shifted. The individual user identity is now the primary gateway to sensitive resources. This creates the core paradox of modern identity architecture. Achieving maximum security requires pushing authentication to the extreme edge through hardware-bound biometrics, while simultaneously governing those endpoints through aggressive, centralized network directories. To understand how this works, we have to trace the architecture from its absolute baseline, starting with the statistical math of local sensors, moving into hardware cryptography, and concluding with global directory federation. Mastering this specific technology stack is the only way security architects can achieve a zero-trust posture without destroying operational usability. At the endpoint, authentication begins with the sensor. Unlike a binary password, a biometric system evaluates physiological data on a probabilistic curve. This evaluation carries two primary risk factors. The first is the false rejection rate, or FRR. This is a type 1 statistical error where the system incorrectly denies access to a legitimate user, creating operational friction and help desk overhead. The second vector is the false acceptance rate, or FAR. This is a type 2 error where the system authorizes an imposter. In an enterprise environment, a single false acceptance is a definitive security breach. This graph displays the mathematical tension between these two errors. The overlapping bell curves represent the match probabilities for authorized users and imposters, divided by a vertical matching threshold. The relationship is strictly inverse. Tightening this threshold to decrease the false acceptance rate inherently increases the false rejection rate. The exact point where these two error curves intersect is the crossover error rate. The CER serves as the industry baseline for comparing a biometric sensor's inherent accuracy, independent of how it is manually tuned. Understanding this math is a prerequisite for meeting the highest compliance standards, specifically NIST Authenticator Assurance Level 3. Tuning an environment for AAL3 mandates pushing the threshold to ensure a near-zero false acceptance rate for sensitive resources. Organizations must accept the resulting higher FFR as a necessary operational cost. This statistical tuning is the bedrock of identity management. If the mathematical threshold on the local sensor is weak,
every subsequent cryptographic defense on the network is immediately compromised. Moving from abstract statistics to the physical hardware of an enterprise laptop, we encounter the next architectural requirement: data governance. Physiological traits are immutable. You cannot reset a compromised fingerprint. Therefore, raw biometric images must never be stored on a device or a server. Instead, systems generate cryptographic templates. The physical pattern is mathematically deconstructed into vector points and passed through a non-reversible hashing function, outputting a randomized alphanumeric string. Modern identity architectures, like Windows Hello for Business, ensure this hashed template is stored exclusively on the local device, never in a centralized database. This localization relies on a specific piece of hardware, the Trusted Platform Module, or TPM. A successful biometric match is a local trigger. It commands the TPM to release a private asymmetric key, which then signs the outbound authentication request.
To prevent malware from silently triggering this key release in the background, enterprise sensors incorporate liveness and 3D depth checks, providing a physical demonstration of user intent. Throughout this entire process, the private key itself never leaves the hardware boundary of the chip. The biometric sensor verifies who is attempting access, while the TPM proves what specific, authorized device they possess. Together, they fulfill the phishing-resistant mandates of AAL3. Localized hardware security solves the endpoint problem, but the enterprise network is a sprawling, hybrid infrastructure. Decentralized hardware keys are ineffective without a centralized authority to verify the public keys and strictly enforce access rules across the network. Directory services like Active Directory and LDAP act as these authoritative repositories. Administrators use group policy objects to mandate biometric sign-in standards globally, ensuring consistency regardless of where the device is located. This introduces a complex architectural challenge. How does a remote laptop that authenticates to a cloud identity provider gain access to a legacy on-premises file share? To bridge this gap, organizations can utilize the Cloud Kerberos Trust Model. This map details the authentication flow. In this model, the cloud identity provider acts as an intermediary broker between the endpoint and the internal network. Entra ID evaluates the initial sign-in, generates a Kerberos ticket granting ticket, and passes it securely to the on-premises directory on behalf of the user. Because this approach eliminates the need for domain controllers to possess certificates from an internal certificate authority, it removes the massive management overhead inherent in older certificate trust models. This makes Cloud Kerberos Trust the most efficient path for organizations wanting to embrace modern biometrics without replacing decades of legacy infrastructure. In operational reality, enterprise identity is highly fluid. Employees are continually hired, promoted to new departments, and terminated. Managing this requires identity lifecycle management, a strategy that directly connects human resource events with directory logic. This cascade illustrates the automated joiner-mover-leaver process. An update in the authoritative HR database acts as an immediate trigger for directory provisioning. When an employee leaves, centralizing identity ensures that revoking a single federated account instantly kills access across the entire global digital ecosystem. This eliminates the persistent threat of orphaned accounts. But verifying an identity is distinct from granting rights. Authentication proves who you are. Authorization dictates what you can touch. Directories manage this through attribute-based access control. The system evaluates user roles, checks device health, and geolocation in real time, enforcing the principle of least privilege dynamically based on context. This automation ensures the directory functions as a real-time policy engine, enforcing the current state of the organization across every connected system. Despite these layered defenses, a final vulnerability remains. Static biometrics verify a user only at the exact moment of login. Once the session is unlocked, the active machine is vulnerable to physical or remote hijacking. Organizations address this gap through continuous authentication, powered by behavioral biometrics. This visual tracks passive micro-interactions throughout an active session. Keystroke dynamics and mouse trajectories constantly feed a central trust score. Machine learning builds a baseline. If a deviation is detected, indicating a different operator, the score drops, triggering immediate re-authentication. This completes the modern identity stack: probabilistic biometric hardware, local cryptographic keys, and automated cloud directories. Enterprise security no longer relies on building a stronger wall.
It requires an unbroken, mathematically proven chain of trust at every single interaction.
Welcome to this explainer. You know, for decades, the entire concept of cybersecurity was basically like building a medieval castle. Thick walls, big moats. But here's the thing, those traditional walls have effectively vanished. Today, the strategy isn't about protecting the castle anymore, it's entirely about guarding the keys. So let's jump right into the absolute critical discipline of identity and access management.
Okay, let's dive into this. Take a look at this staggering statistic. 74%. A massive 74% of all security breaches involve a human element. We're talking about the misuse of privileges, stolen credentials, or, just simple configuration errors. Only 26% come from other vectors. And this is exactly why identity and access management, or IAM, isn't just some back-end IT function anymore. It is the new critical perimeter.
Let's briefly map out our journey today through these CISSP Domain 5 principles. We're going to conquer this topic in 6 steps. 1. Identity is the new perimeter. 2. The digital identity lifecycle. 3. Automating away human error. 4. Guarding the crown jewels. 5. The danger of orphaned accounts. And 6. Trust but always verify. All right, jumping straight into section 1. Identity is the new perimeter where we establish trust. To actually control and establish trust across all your digital assets, it really all comes down to the IAAA framework, which breaks down into 4 sequential steps. First up is identification. This is simply claiming an identity, like typing in a username. Second is authentication, where the system actually verifies that claim using a password, a token, or biometrics. Third is authorization. Once we definitively know who you are, what specific access rights do you actually have? And fourth is accountability. This uniquely links every single action back to a specific individual, giving us an undeniable audit trail if things go sideways. Now, what's really interesting about this is the golden rule of authorization, the principle of least privilege. The core idea here is incredibly simple, but man, is it powerful. You grant someone only the absolute minimum level of access necessary to do their specific task. Nothing more. Why is this absolutely crucial? Well, because if an account gets compromised or an employee just makes an honest mistake, this limitation drastically minimizes the blast radius of the damage. I mean, you'd never hand over the master keys to the entire building if someone just needs to get into a single room, right?
Moving right along to section 2, the digital identity lifecycle, which is really a chronological journey.
Remember, identity isn't just a static event. It's an ongoing narrative that builds across 4 distinct phases. Phase 1 is provisioning. This is your starting point on day 1, ideally triggered by an authoritative source of truth like your HR system, automatically mapping job attributes to baseline templates. Phase 2 is maintenance. That's the continuous day-to-day adjustment of permissions as people move around. Phase 3 brings in user access reviews, acting as a vital audit to catch any overprivilege. And finally, Phase 4 is deprovisioning, the immediate systematic revocation of all access the exact moment someone leaves the company. But during that maintenance phase, organizations face a massive, silent threat. We call it role creep. Think about your own career for a second. You move between projects, maybe switch departments, or you got a promotion. You get new access for those new tasks, but does anyone ever remember to proactively take away your old access? Honestly, usually not. And that gradual accumulation turns yesterday's perfectly valid access into today's quiet, completely unmonitored risk. Which brings us to section 3, automating away human error as a strategic imperative. This brilliantly illustrates how moving away from slow, manual help desk tickets is a foundational requirement for modern resilience. When you look at manual management, you see incredibly slow response times, poor audit postures, a super high risk of human error, and inevitably orphaned accounts. But automated management, that delivers real-time synchronization with HR, consistent rule-based precision, superior audit trails, and instant deprovisioning. As companies scale up, it becomes physically impossible to secure an enterprise using human cues. Automation really is the only way forward. Okay, let's raise the stakes with section 4, guarding the crown jewels, focusing on privileged access and authorization. So how do systems actually decide what a user can do once they're inside? Well, there are 4 primary authorization models. RBAC, or Role-Based Access Control, ties permissions straight to job roles, which makes it highly scalable for standard enterprise employees. ABAC, Attribute-Based Access Control, is much more dynamic. It makes context-aware decisions based on attributes, making it perfect for cloud environments. Then you have MAC, mandatory access control, which relies on strict, rigid security labels. Think military and government systems. And finally, DAC, discretionary access control. Here, the resource owner dictates who gets access, which is flexible for internal collaboration, but definitely prone to permission sprawl. But listen, when it comes to highly privileged administrative accounts, those traditional models just aren't enough. So the crucial point here is zero standing privilege, or a ZSP. Historically, IT admins had always-on permanent administrative rights, and that creates an enormous, persistent attack vector. ZSP eliminates that target entirely by replacing those dangerous permanent rights with temporary access that expires automatically the second a specific task or timeframe is done. We operationalize this zero standing privilege idea using just-in-time, or JIT, access patterns based strictly on location, action, and time. You can do this in 3 ways. Temporary access elevation temporarily boosts an existing account. Broker and remove access uses a vaulted connection for a fixed, limited duration. Or you can use the ultimate secure method, ephemeral accounts. This is where a dynamic, one-time account is created out of thin air, does the job, and is completely destroyed in real time. It drastically shrinks the window of opportunity for any attacker. Let's move to Section 5, the danger of orphaned accounts. We like to call these identity dark matter, and they make for some real ghost stories. 83%. That is an absolutely staggering number. It's the percentage of former employees who claim to still have active access to company resources post-termination when manual processes are used. I want you to reflect on your own experience for a minute. Have you ever left a job and realized, maybe a week later, that you could still log into an old software portal or read internal emails? When manual processes fail, the invisible backdoors are just left wide open. Which leads us to a terrifying question that every single security professional really needs to ask themselves. What actually happens when a digital identity outlives the employee it belongs to? Well, the real-world consequences are literally catastrophic. Just look at this recent history. In 2019, Capital One suffered a massive breach when a dormant IAM role was used to exfiltrate over 100 million records. In 2021, the Colonial Pipeline attack started simply because attackers found an old, inactive VPN account that lacked multi-factor authentication. And with emerging threats like the Akira ransomware, we're seeing major breaches originating from ghost third-party vendor accounts that were never deactivated. It proves that immediate deprovisioning across all your cloud and SaaS platforms is absolutely non-negotiable. Finally, we arrive at Section 6, Trust but Always Verify, looking at administrative accountability. Accountability is basically how we watch the watchers. ISC2 defines 4 crucial logging practices here. First, prioritization, defining exactly what you need to capture based on legal or policy rules. Second, policies and procedures, to make sure every necessary event is actually recorded. Third, log infrastructure, like a SIEM platform, for tamper-proof storage. And fourth, staff support, meaning training your team to actually manage and analyze these logs. Keep in mind, for ultra-high-risk sessions, this might even mean full video session recording to get undeniable forensic evidence. But, honestly, just looking at noisy logs after a breach, that isn't enough anymore. Modern organizations are adopting Identity Resilience Surface Management, or IRSM. Instead of just logging things, IRSM proactively monitors for hybrid identity drift, that dangerous gap between your intended security policy and reality. It actively tracks unauthorized group additions and detects complex toxic permission combinations in real time. It gives you context-rich alerts, keeping your actual security state perfectly aligned with what it needs to be. And that brings us to the end of this explainer. I want to leave you with this final, provocative thought to take back to your teams. Is your organization still treating identity as a simple IT task, or have you elevated it to a critical governance decision? True security today doesn't come from building thinner castle walls. The walls are gone. True security means mastering the keys. Thanks for joining us. Keep learning and stay secure out there.